Good morning everyone. I am Gayatri Devi from Computer Science and Engineering. Today my topic is vector calculus proof. The example of the vector calculus proof is shown as below. Show that del a into r by r power n is equals to a by r power n minus n into a into r by r power n plus 2. Introduction. In this presentation, we will derive the gradient of the scalar field f is equals to a into r by r power n, in which it is shown that a is a constant vector and r is the position vector. Preliminaries. Let us consider a is equals to constant vector, that is a of x, a of y and a of z. R is equals to position vector, that is x of I bar plus yj bar plus zk bar. R is equals to mod r is equals to square root of x square plus y square plus z square. Here a into r is the scalar dot product. We will use vector calculus identities and the quotient rule. Step-by-step derivation is shown as below. Let f of r is equals to a into r by r power n. We need to compute del f. Let us define phi is equals to a into r. Xi is equals to r power n. So f is equals to phi of xi. So f is equals to phi by xi. Now apply the vector calculus identity quotient rule for gradient. Del of phi by xi is equals to xi del phi minus phi del xi by xi square. Step 1. Compute del xi. Phi is equals to a into r is equals to ax of x plus ay of y plus az of z is equals to, that is del phi is equals to a. Since a is constant, the gradient of the dot product gives you the vector a. Step 2 is compute the del xi. Xi is equals to r power n. R power n is equals to r square whole power n by 2, where del xi is equals to del into r power n is equals to d by dr into r power n into del r. Dou by dou r into r power n is equals to n into r power n minus 1, where del r is equals to r by mod r is equals to r by r. So del r power n is equals to n into r power n minus 1, comma, into r by r is equals to n into r power n minus 2 into r. So here del xi is equals to n into r power n minus 2 into r. Step 3. Apply quotient rule, that is del f is equals to del a into r by a power n is equals to r power n into a minus a into r of n r power n minus 2 into r by r power 2n. Factor terms, that is a by r power n minus n into a into r by r power n. The final answer for the vector calculus is del of a into r by r power n is equals to a by r power n minus n into a into r by r power n plus 2. At last I conclude that we used vector identities and quotient rules to derive the expression. The result is useful in vector calculus and physics, especially in electromagnetics. The way we used the vector calculus is used two vector identities and quotient rule to derive the expression. It is used in vector calculus and physics, especially in electromagnetics. Thank you.